Hello everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I will be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous video, I was actually discussing the exercise questions which were there in the 8th chapter of 9th standard science subject. So in this particular video, we will see the remaining questions which were there in this exercise. So coming to the 13th question in this particular exercise, here there is a bullet which is actually traveling at 150 meter per second velocity. So now the velocity of this particular bullet is 150 meter per second, and this particular bullet is actually hitting a wooden block, and after hitting this particular wooden block, this particular bullet penetrated that particular wooden block. So now if you assume this as a wooden block, then bullet has penetrated through this particular wooden block. You have to find out how much distance it has penetrated inside this particular wooden block. So this particular distance you have to find out. So S means distance. So that is distance of penetration in this particular case. So now before hitting the wooden block, the velocity of bullet was 150 meter per second, because bullet is traveling at 150 meter per second. So initial velocity of bullet is 150 meter per second. So after traveling 0.03 seconds inside the wooden block, bullet comes to rest. So that means final velocity is 0, and the time taken to reach this 0 velocity, that means for this bullet to come to rest inside the wooden block, it has taken 0.03 seconds. So now using this particular data, you have to find out the penetration distance inside that particular wooden block. Second equation is S is equal to ut plus half at square. So now I will write this equation in a new slide. So S is equal to ut plus half at square. So here u is initial velocity. In the place of acceleration, we can write this as ut plus half v minus u divided by t into t square, because according to the first equation of motion, v is equal to u plus at. So that means here a will be equal to v minus u divided by t. So the same thing I am substituting in the place of a. So now S is equal to ut plus half v minus u into t, because here 1t and 1t gets cancelled, because t square means it is t into t. So 1t in the numerator and 1t in the denominator gets cancelled with each other. So 1t will be remaining in the numerator. So v minus u into t. So the equation what we are getting is S is equal to ut plus half v minus u into t. So now we can substitute the values which we have. So the initial velocity is 150 meter per second, which is there in SI unit itself. So directly I can write 150, and t is 0.03 second plus 1 by 2 into final velocity is 0, and the initial velocity was 150 meter per second. So 150 into 0.03. So now if you do 150 into 0.03, that is 4.5 plus 1 by 2 into minus 150 into 0.03 is there, because 0 minus 150 is minus 150. So minus 150 into 0.03 is, again it is minus 4.5. So now minus 4.5 divided by 2 is there. So S is equal to 4.5. So here minus 4.5 divided by 2. So now we are actually getting S is equal to 4.5 minus 4.5 divided by 2. So 4.5 divided by 2 is 2.25. So 4.5 minus 2.25 will be there. So when you do 4.5 minus 2.25, it will be equal to 2.25 meter, because everything we have calculated in SI units. So distance will also be there in SI units, that is in meter. So that means after traveling 2.25 meter inside wooden block, bullet has come to rest. That means distance of penetration of that particular wooden block inside that wooden block by the bullet is equal to 2.25 meter. So now in this particular same question, you have to calculate the force exerted by wooden block onto the bullet as well. So here mass of the bullet is given. So mass of the bullet is 10 gram, and we have also calculated the distance of penetration. Along with that, we know final velocity is 0 and initial velocity is 150 meter per second. So now we also know time is 0.03 second. So force is equal to mass times acceleration. In the place of acceleration, I can write this as V minus U divided by T. So now F is equal to mass times acceleration. So mass is 10 grams. So 10 grams means that is 0.01 kg into velocity. Final velocity is 0 minus initial velocity is 150 meter per second divided by 0.03 second. So 0.01 divided by 0.03, I can write this as 1 by 3 into minus 150. 0 minus 150 is minus 150, that is equal to minus 150 divided by 3. So now F is equal to minus 150 divided by 3. So 3 ones are 3, 3 5s are 15. So 1 0 is there, 0 will be there. So minus 15 Newton. So why this minus symbol is coming is because the force exerted by the wooden block is in the opposite direction to the direction of motion of the bullet. So that's why this particular minus sign is coming. But in the question they have asked to calculate the magnitude of force. So when they ask for magnitude of force, then you should ignore this minus sign because we are just focusing on the magnitude of the force. So here minus indicates the direction of force and 50 is the magnitude of force. So that's why magnitude of force, so magnitude of force is equal to, you can remove that minus, so that will be equal to 50 Newton. So 50 Newton of force is applied onto the bullet by wooden block, where this particular force is in opposite direction to the direction of motion of the bullet. Coming to the 14th question in this particular exercise, here on a particular floor there is a wooden block which is having mass equal to 5 kg. And there is one more object which has mass equal to 1 kg. So let's say this is one more object which has mass equal to 1 kg. And this particular object is moving in a straight line and it is actually hitting this particular wooden block and it is sticking with the wooden block and it is moving the wooden block. So these two objects move off together after this particular object hits this particular wooden block. That means one particular object which has mass equal to 1 kg is hitting a wooden block which has mass 5 kg. It is sticking to the wooden block and with that particular impact these both objects are moving together. So now you should actually calculate the initial momentum of this particular object and the final momentum. So now what will be the initial momentum? If you want to calculate the initial momentum, so let the initial momentum be P1, that is equal to m times, that is mass 1 times velocity 1. So what is the mass 1 here? Mass 1 is, that is m1 is equal to 1 kg and this particular 1 kg massed object is traveling at 10 meter per second. So its initial velocity is 10 meter per second. So the initial momentum will be equal to 1 into 10, that is 10 kg meter per second. So 10 kg meter per second is the initial momentum, and according to the law of conservation of momentum, so according to the law of conservation of momentum, so according to this law, the momentum of the total system will always be conserved. So that means here final momentum will also be equal to, let's say that is P2. So final momentum will also be equal to 10 kg meter per second. So what is final momentum? Final momentum will be m2 v2. So now you have to calculate this particular velocity also. That is, when this particular 1 kg object is hitting 5 kg object and it is sticking with that particular 5 kg wooden block and it is moving, like both are moving together. So what is that final velocity? Because now this particular object which was moving at 10 meter per second. When it has hit this particular object, obviously its velocity will reduce. The total velocity will reduce, but the total mass of the system has increased because 1 kg plus 5 kg is 6 kg. That means here velocity has reduced, mass has increased. That means momentum will be conserved because momentum is mass times velocity. So here velocity is decreasing and mass is increasing. That means here momentum is conserved but velocity has changed. You have to calculate that change in velocity. So now the new mass m2 is 6 kg because now that particular 1 kg massed object has been stuck to that 5 kg wooden block. So 1 plus 5 will be equal to 6 kg. So this m2 is equal to 6 kg. So that is equal to m2 into v2 is equal to 10 kg meter per second. So now you have to calculate what is the final velocity of both of them. Now both of them are moving together with certain velocity. That velocity you have to find out. So that velocity v2 is equal to 10 divided by m2. Here m2 is 6 kg. So 10 divided by 6 will be there. So here 2 5s are 10, 2 3s are 6. So 5 by 3 meter per second is the velocity. So initial momentum is equal to 10 kg meter per second. So this is the initial momentum, that is 10 kg meter per second, and this is the final momentum, that is also equal to 10 kg meter per second. The velocity, the final velocity of both of them when they are moving together is equal to 5 by 3 meter per second. Coming to the 15th question, here they have asked to calculate the initial and final momentum of a particular object where the mass of that particular object is 100 kg. Initially it will be traveling at 5 meter per second and gradually uniformly it will accelerate to 8 meter per second in 6 seconds. So initial velocity of this particular object is equal to 5 meter per second and the final velocity of this particular object is equal to 8 meter per second, and to reach this final velocity it has taken time 6 seconds. So mass is equal to 100 kg. So now you have to calculate initial momentum and final momentum. So to calculate initial momentum, you can consider initial momentum as p1, that will be equal to m times u. U is the initial velocity. So mass is 100 kg into u is 5 meter per second. So 5 into 100 will be 500 kg meter per second. This is the initial momentum. Final momentum p2 will be equal to mass times final velocity v. So 100 into final velocity is 8. So 8 into 100 is 800 kg meter per second. So this is the initial momentum 500 and the final momentum is 800 kg meter per second. So now you have to calculate the force exerted by the object in order to accelerate from 5 meter per second to 8 meter per second velocity. So F is equal to mass times acceleration, where acceleration is equal to v minus u divided by t. So here mass is equal to 100 kg, v is 8, u is 5 meter per second. Everything is in SI units, so you can directly substitute. So in the place of u, you can write 5. So 8 minus 5 divided by t is 6 seconds. So now F is equal to 100 into 8 minus 5 divided by 6. So 8 minus 5 is 3. So 100 into 3 divided by 6. So 3 ones are 3, 3 twos are 6. So 100 divided by 2 will be there. So that is equal to 50 Newton. So 50 Newton is the force exerted by the object when it was accelerating from 5 meter per second to 8 meter per second in 6 seconds time. And initial momentum was equal to 500 kg meter per second and final momentum is equal to 800 kg meter per second. So coming to the 16th question, here Akhtar, Kiran and Rahul are 3 friends who are traveling in a particular car, and suddenly when they are traveling in a car, a small insect come and hit the windshield of this particular car, and this particular insect dies. So now all 3 of them will come to different conclusions by seeing this. So where Akhtar and Kiran gave the wrong conclusions, whereas Rahul gave the right conclusion. So what was the conclusion of Rahul? So Rahul concluded that force exerted by both insect and the windshield are equal and opposite. So here forces are equal and change in momentum is also equal. So here Rahul is giving a conclusion, that is forces are equal and the change in momentum is also equal. So this is the conclusion given by Rahul, and this conclusion is correct because here when a particular insect hits windshield of a particular car, so let's assume this as the windshield of a particular car. So if this is a car, then if this is a windshield of this particular car and if this insect is hitting this particular windshield, so the same amount of force is exerted by windshield onto the insect, and insect will also exert same amount of force onto the windshield. But here both of them are experiencing same amount of force and both of them having same change in momentum. But still here insect has got greater hurt whereas windshield has got less hurt. Why this has happened? Let us assume windshield force as F1, that is the force applied by windshield onto the insect as F1 and the force applied by the insect onto the windshield as F2. So here F1 and F2 are equal and opposite to each other. So now we will just consider the magnitude of force. So if we just consider the magnitude of force, then mass times acceleration, that is mass 1 times acceleration 1 is equal to mass m2 times acceleration a2. So here this particular mass m1 and acceleration a1 is the force f1, that is the force applied by windshield onto the insect, and this m2 into a2 acceleration, this particular force is f2. This F2 is the force applied by insect onto the windshield. So now here M1 is A1 is equal to M2 A2. Here I am not putting any minus sign for M2 A2 because here I am only considering the magnitude of force. So here I am only considering the magnitude of forces. So that's why I am ignoring the sign. Here you can see both have equal amount of force experience. That means the amount of force experienced by the windshield is equal to the amount of force experienced by the insect. But here insect has got greater hurt because here it has greater acceleration. So here basically what has happened is that when insect is colliding with the windshield of the car, because it has very less mass, in order to account for that greater force, it has to be having more acceleration. More acceleration means more change in velocity. So here basically deceleration is happening for insect. So here we will understand this through this particular equation. So now here A1 is the acceleration 1 and A2 is the acceleration 2. So here acceleration is change in velocity and here also acceleration is change in velocity. So now we will substitute that using equation 1, equation of motion 1. So A is always equal to V minus U by T. So here V1 minus U1 divided by T is equal to M2 into V2 minus U2 divided by T. So here time is same but mass are different. Now M1 is very much greater than M2 because M1 is the mass of the car and M2 is the mass of the insect. That means insect's mass is very less compared to the car's mass. So here because mass is very less, change in velocity should be very much higher for insect compared with the car, because here m1 into acceleration 1 is equal to m2 into acceleration 2. That is change in velocity times mass of car is equal to change in velocity times mass of insect. So now insect mass is very less and car mass is very much more. So that means here Since mass 1 is greater than m2, v2 minus u2 will be greater than v1 minus u1. So that means change in velocity. So this is change in velocity. So change in velocity of insect will be more than the change in velocity of car. Because car has more mass, it will have less change in velocity. Because insect has very less mass, the change in velocity of insect will be more. Because change in velocity of insect is more, it will be squashed on that particular windshield. So that's why here insect gets more hurt because its mass is very less, hence it undergoes greater change in velocity. But since mass of car is very high, because mass of car is huge, this particular car will experience less change in velocity. Forces are same. Here the force exerted by windshield onto the insect is same as compared to the force exerted by insect onto the windshield. So forces are same, but mass is different, change in velocity is different. So now in order to make these forces equal, insect should have undergone more change in velocity in order to accommodate that particular less mass. So because it has very less mass, it will have more change in velocity, and car has more mass, hence it will be having less change in velocity. So this you can understand through this equation. So that's why insect will get more hurt compared to the windshield. So in order to explain this, you can write this mathematical steps, and in a short brief note you can explain this in your own words. Coming to the 17th question, there is a dumbbell at height 80 centimeter from the ground. So at 80 centimeter height there is a dumbbell which has mass equal to 10 kg. So mass is 10 kg and the height is 80 centimeter, and acceleration due to gravity is equal to 10 meter per second square. So basically they have given acceleration, they have given mass, and they have given the distance. Now you should calculate how much momentum this particular dumbbell will transfer to this floor when this particular dumbbell is dropped onto the floor. So now you have to calculate momentum exerted by the dumbbell onto the floor. So to calculate that, you should require the final velocity. The final velocity is the velocity just before this particular dumbbell hitting the ground. So whatever the velocity is there for this particular dumbbell just before it hits the ground, so that velocity you can take, and you can take the mass of that particular dumbbell, and you can calculate the amount of momentum which that particular dumbbell will be carrying just before it is hitting the ground. Because here acceleration is coming into picture, momentum will be increasing because there is increase in velocity. So because there is increase in velocity, there will be increase in momentum. So you should calculate momentum just before the dumbbell hits the ground, so that you can tell that particular momentum was transferred to the ground. So now in order to calculate that, you should calculate the final velocity of the dumbbell just before it hits the ground. So in order to calculate that, you require the velocity of that particular point. So if you assume that as your final velocity, so then this particular velocity will be v. So let's say this particular final velocity as v and mass is m. So m times v will be your momentum. So now you have to calculate this particular momentum of this particular dumbbell which it will be transferring to the ground. So now in order to calculate this momentum, you require this particular final velocity. So now what will be the final velocity? You can use this formula, that is v is equal to u plus at. So here we know that this particular dumbbell is dropped from 80 centimeters. So initially it was at rest. So that means we can assume that this particular dumbbell was initially at rest. So that means here initial velocity will be equal to 0. So here v will be equal to at. So in order to calculate this particular velocity, we want acceleration and time. We know that acceleration due to gravity is 10 meter per second square. So that means here in the place of acceleration, we can substitute this 10. But we don't know what is the time. So in order to calculate this time, we can use second equation of motion, that is S is equal to ut plus half at square. So here u is 0, so this entire term becomes 0. So that will be equal to half at square. So now we have the equation s is equal to half at square. So now we know what is the acceleration, we know what is the distance, that is 80 centimeter. So in the place of 80 centimeter, I will write 0.8 because everything should be written in SI unit. So 80 centimeter means it is equal to 80 into 10 power minus 2 meter. So because centi is equal to 10 power minus 2. So 80 into 10 power minus 2 is 0.8 meter. So I am substituting that 0.8 in the place of distance is equal to 1 by 2 into acceleration is 10 meter per second square into t square. So now you can bring this 2 and 10 to the LHS. So it will be equal to 0.8 into 2. So whatever term is there in the denominator will go to the numerator, and whatever is there on numerator will come to the denominator. So 0.8 into 2 divided by 10 will be equal to t square. So t square is equal to 0.8 into 2 divided by 10. So 0.8 into 2 will be 1.6 divided by 10. So 1.6 divided by 10 means it is equal to 0.16. So now you can take square root. So when you take square root, it will be plus or minus, but time cannot be negative. So always you should take only plus. So plus square root of 0.16. So 0.4 will be the square root of 0.16. So that means here time is equal to 0.4 seconds. So now you know what is the acceleration. Acceleration is 10 meter per second square, and you know the time. Time is equal to 0.4 second. So now you can calculate the final velocity. The final velocity is equal to u plus at, where u is 0 because initially it was at rest. So at is there. So at means 10 into 0.4. So v will be equal to 10 into 0.4, that is 4 meter per second. So now you got the velocity. So momentum just before it hits the ground is equal to mass times velocity just before it reaches the ground. So in the place of mass, you can write the mass of this particular dumbbell, that is equal to 10 kg into velocity is 4 meter per second. So 10 kg into 4 meter per second will be 40 kg meter per second. So this is the momentum which this particular dumbbell transfers to the ground. That means just before hitting the ground, the dumbbell will be having momentum equal to 40 kg meter per second. With that momentum, it is hitting the ground. So that's why that ground will receive 40 kg meter per second momentum. So this comes to an end for this particular chapter. Like this, if you want to learn more physics, chemistry and mathematics, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.